In this video, let's take a look at Crankk, which is supposedly a Helium competitor. Crankk is a newer project and it aims to be IoT based, so LoRa WAN, and it pretty much aims to compete directly with Helium. And so let's take a look and see what this is all about. Take a look at what they're calling their light paper, go through it, and I'll give you my thoughts and opinions kind of on each section of the light paper. Before I jump into the light paper, I do want to show you their website. So it's Crankk with 2ks.io, and they're using Cadena as their blockchain. And it's essentially Helium, right? They're trying to provide LoRa coverage across the globe. And as I mentioned, it's very new. And if we scroll down, you can see there's only 347 miners online. And so far, they've distributed 198,000 tokens. And they've done just over 65,000 proof of coverage checks. And before we jump to the light paper, we'll just take a look at the tokenomics since it's right here on the main page. And essentially what it boils down to is they're using Cadena's chains, and I believe they cover this more in the light paper. But what that means is there can essentially be like 20 subchains, and their token supply is 10 million per chain. So it's 200 million in total. The initial supply, it says virtually zero. Not sure what that means, other than they're basically saying there was no ICO. But where it says virtually, that's kind of weird. Either it's zero or it's not zero. So that one's kind of odd. But they're basically saying the only way to accumulate Crankk is to earn it. 80% of the tokens are allocated for miners. The project takes 8% for development. And then here it is. A new chain will be opened after 7,500 active gateway nodes. So for every 7,500 nodes or devices, hotspots, they're going to then spin up another chain until they have all 20. Obviously, they're saying that you're going to earn more tokens that way. I guess once it's on the network, it's locked to that chain. So that's kind of interesting. And tokens will be distributed evenly over 20 years. Before I jump into the light paper, let's go ahead and jump over to the miner section so that you can see the kind of hardware they're looking at. And it's Raspberry Pi 4 comparable. The LoRa gateway, obviously lower in power consumption being a Raspberry Pi or any single board computer, whichever they go with. It's got Ethernet and Wi-Fi antenna included. Pretty much the same as Helium for the most part, other than the fact that their miners are quite expensive considering we're in a bear market. So the North American model, and you can buy these right now, they're claiming to ship within 3 weeks. It's $500 plus $20 shipping for the US, which is the 915 megahertz frequency. And they also have Europe, and the Australia one isn't released yet. That one is coming soon. When I first looked at this project, it had coming soon on the North America ones, but they are available now. So I anticipate Australia will probably be coming really soon. Let's jump on over to the light paper. And they put this up on Medium. And so essentially, proof of coverage crypto network on Cadena. So here we go. Let's walk through this. So it says Crankk is a Helium-like crypto network, and this is the very beginning. Helium is great, or it has been great, but there's still a huge backlog of miner orders. In the order of millions, I hear. This is no longer applicable, right? Pretty much everybody has got their miner or has had the option to cancel their Helium miner. Mining returns are already pretty low. I would agree with this. Returns are pretty low. However, the network's not really oversaturated, in my opinion, when you look at the coverage map. One of those would not be a deal breaker, but together, those may be. We didn't start Crankk to be a copycat, and it won't be. We followed our heart to create a truly distributed network of independent nodes to do something useful and enable node operators to make tokens in the process. We didn't take any code or ideas from Helium except the goal of creating a proof of coverage network. So those where I have a problem, right? They're saying that they're not a copy of Helium, right? However, Helium was really kind of the first proof of coverage network. That is their whole thing, right? These companies or, these educational institutions, anybody out there, you might have a robot, you might have, some type of IoT device that you want to connect to a network. You may not necessarily have Wi-Fi. You can connect it to these nodes, and you can basically interact not only with that global network, but you can interact with the internet through those devices. And that's essentially what Helium is, right? It's providing and building out that network of devices. So them saying that they're not a copycat, I would say, yeah, they didn't build their own blockchain, but from a technology standpoint, they are pretty much the same thing. Moving on. It runs on the existing blockchain called Cadena, and Crankk is a token on the Cadena network. The hardware is made up of a Raspberry Pi and a gateway module. One of the bottlenecks of Helium is the licensed hardware model. I will agree with this. So early on, when Helium first started, you could buy a Raspberry Pi and you could buy the LoRa hat for it, and you could register it with the Helium network. Helium got away from that model. They moved from the DIY model to a licensed model where you had to buy it from a licensed manufacturer. If you tried to build your own, you couldn't just acquire a license for it. And so that is obviously a big thing. Now what they're going to say is, we'll start with our own hardware, but plan to allow open source hardware when the network starts showing some robustness. This should eliminate some of the concerns. So they're taking the opposite approach that Helium took. But what they're doing is they're saying, we're going to build all the devices from the beginning. If you have a DIY device, you can't put it on our network. That means you can't take existing Helium miners and put it onto the Crankk network, right? You can't take a single board computer, add a IoT module to it, or a LoRa module, and throw it on the network. They're essentially limiting themselves from building out the network from the beginning. They essentially want you to buy their hardware. This is not that much indifferent from what SE Prime is doing with their XA miners, right? They kind of started as DIY, and then they basically dropped it and said, you know what, you DIY guys, you have to buy a license now if you want to get any data on our network. If you don't buy a license, you're going to get kicked off the network, right? If you don't want to buy a license, you have to buy one of our devices, one of our storage devices, which are thousands of dollars. Moving on. Crankk nodes are not blockchain nodes. Cadena is proven robust, secure, multi-chain, proof of work network with many petahash per second total hash power. Yeah, because it's ASIC controlled. This should eliminate many other concerns. There are multiple attributes of Cadena that are beneficial, but again, we'll come back to those later. Crankk is focused on proving coverage. How do you prove coverage, you might ask? Well, we didn't see any other way but to implement something similar to Helium in terms of witnessed broadcasts. It is impossible to prove that Alice sent something to Bob and they both lied about it or told the truth. And so this is kind of, they're getting into how people were cheating the system with Helium early on, right? Where you could basically fake your location and you could fake the packets, right? You could essentially build almost like a VLAN of, or a VPN of hotspots. So proof of coverage aims to, prevent that from happening. I'm not going to read through all their scenarios there. But in the end, if the majority of the network is honest and listens as agreed, then the majority should be able to prove the validity of such claim. Another concern is those who didn't witness it but claim they did should be blocked from getting rewarded. And this is what Helium did with, blocking hotspots. Fair exchange, blah, blah, blah. TTPs are also selected randomly for each communication exchange, so collusion is a lot less likely. Alright, here's where they talk about LoRa WAN, which is a radio communication protocol that Helium and also Crankk serves up as a service for potential users like utility companies, GPS track manufacturers, etc. to provide coverage for. The idea is that if the network provides good coverage for a geographic area, then it can be relied on without thinking much about where exactly the service is needed within that area. Coverage for that area is proven by the network. A failure would be if coverage shows as proven for the area, but somehow radio package transmitted by smart meters or trackers is not picked up by the network because maybe some of those nodes successfully lied about providing coverage for that area. The goal of the proof of coverage network is to prevent this from happening. But there's also another consideration. As you might imagine, the protocol designers didn't optimize the network to be distributed. They optimized it to be centralized. What it means, although you can operate the gateway and connect it to central server of your choice. There's still a central server. The reason for that is that the LoRa WAN is actually a client device that needs to be registered with one or more central servers that know the client's device secret to be able to decrypt the message. Since there are multiple layers, only a central server is supposed to know this key and not participate in other layers. This way an encrypted message travels through the network, but the actual message remains secret until the central server decrypts it, and with its own central access control, only the actual intended recipient is able to see it. There are other network management considerations as well that make centralization a seeming necessity. Of course, this could probably be mitigated and the system made less centralized, but that would take extra effort, and that was also probably not a goal. As a conclusion, we can say that LoRa is not a really good candidate to build a distributed network out of, but at the same time very useful. Here we go. Why did they choose Kadena? I think this is the best part. There are so many reasons to build on Kadena. Kadena is a true layer 1 proof of work crypto with special quirks. It has a high throughput, estimated to be 480,000 transactions per minute, Lisp-like contract language called Pact, which is intentionally Turing incomplete. Turing incompleteness is a good thing here to avoid problems that Ethereum has. Kadena has relational database behind it. It's a very good thing. Blockchains are replicated databases that can agree on a consensus state and keep propagating it. If it's a database, then a logical design choice would be to actually employ one. Most don't, but Kadena does. And virtually zero gas fees. If you guys use Flux and you're familiar with, cashing out parallel assets and converting them to Flux, you're aware of Zelcor's gas station that they have for Kadena. This will give you a general idea of what those gas fees are. You're still going to have to pay gas fees on every transaction, which is another downfall here. Here we go. Why not have our own blockchain? We could say things like, why reinventing the wheel? But that's not the real reason. It will be enough of an undertaking to build a distributed network for a true, practically working proof of coverage, taking on the responsibility of building the blockchain with it. It just exceeds our ambitions. It still involves solving multiple technical challenges, integrating the blockchain and smart contracts to provide a good token solution, formulating governing smart contracts that check and enforce expected client behavior, enhancing ChirpStack, which is the open source LoRa server solution to implement the gateway and the gateway ping checks, and arranging the chirp stack components, which would be the gateway bridge, the network server, the application server, in a way that serves both functionality and proof of coverage necessity. One of the things I will say with this is the Helium blockchain with the, I think it's like 10-minute block times. To me, that was a big downfall. However, they were trying to separate themselves apart from the pack by going to Cadena. With Helium moving to Solana, I think they're basically going to be the same thing. I know a lot of people would say Solana's not reliable, it's not stable. I think they are looking at potentially forking to a better solution for Solana. But Solana has phenomenal transaction times, especially compared to Helium. Alright, moving on, the gas fee saving conundrum. Cadena is great, I think I've already said that, but it's replicated database just like any other. Follow logic of blockchains. The same smart contract function needs to execute on many nodes without varying processing power to arrive at a consensus. In the Cadena packed smart contract language, there are SQL select statements available that would make it really useful to orchestrate coordinated efforts over many network clients. However, there are resource-intensive operations and can potentially create performance bottlenecks. It's enough if some nodes slow down for the entire network to slow down. The only way for Cadena and other blockchains to remain resource-checked is the implementation of gas fees. Right? If you exchange Ethereum, you know very well, what the gas fee entails. And it's really a way for controlling and prioritizing transactions in the buffer. Cadena has virtually zero gas fees for most operations. Select operations are not one of those since recently. This makes it a bit more difficult to orchestrate actions over a large number of nodes, but certainly not impossible. The workaround here is to come up with an execution plan outside of the blockchain and have it checked by the blockchain, as opposed to letting the blockchain come up with the plan itself. The tokenomics we actually covered at the beginning of the video, so I'm going to kind of skip over this. The key thing here is they're using the 20 Cadena chains. So the max supply is going to be 20 million, but it's only going to be 10 million per chain. And then a new chain will be opened after every 5,000 active gateway nodes. Let's see. Alright, the witness rewards. Every gateway is instructed by the blockchain to send a ping every 4 hours. For the sender to get reward, the pings need to be sent when instructed and received by at least one witness. This is the same as Helium. Half of the allocated rewards go to the sender, the other half is distributed equally among all valid witnesses of the same ping. The total rewards for one such exchange is calculated based on the expected number of pings on the network per day to add up to the total planned token distribution per day. One minor caveat is that below 100 active gateways per chain, the reward for one ping is limited to 1 token for the sender and 1 for the witness. So you're never going to get more than 1 full token every 4 hours, essentially. Gateway clumping. Gateway clumped together and witness one another is detrimental to the coverage they provide. I wouldn't say it's detrimental as much as it's not necessary. Ultimately, they are separated by hearing distance or some fraction of it. Looking at how successfully Helium has fared in this regard, there doesn't seem to be an exact and easy way to do this. Gateways do communicate exact timing RSSI, SNR values of reception event, along with the LoRa specific protocol parameters, so there is a basis to compare them. There's also a GPS receiver included with the gateway so that it provides GPS coordinates as well as accurate time. And this may be the reason for the elevated price as well. Just keep that in mind. These do have GPS receivers in them. But with all this information, considering GPS information can be spoofed, very easy to do, Although not necessarily trivial, clumping detection is still probabilistic check and not an exact one. That being said, initially Crankk will not penalize clumping. There will be clear communication with the exact time given when the network will start to assign lower rewards to clump network gateways. Basically what they're saying is if you get in early on, there's not a lot of gateways in your area, technically you could put 2 in your home and they'll kind of ping off of each other. Check out their Discord for any updates on this. This light paper was written, I think, back in May, so just keep that in mind. Consensus group notes. It's primarily the necessity of a trusted third party that the witness is validation code cannot be implemented on the blockchain. It could, but you always have to assume the data on the blockchain is essentially public. It does not mean that it takes zero effort to get to it, but it definitely is possible. That means that blockchain cannot assume the role of a trusted third party. The point of the trusted third party is that it can receive privileged information signed by the sender and encrypted with the trusted third party's public key. This eliminates the possibility of nodes that didn't hear the ping lying about it and saying that they did. Also, the trusted third party can perform the check and comparison of all radio reception parameters and validate those. It's kind of like a multi-step validation that it can do. It greatly reduces the chance of a consensus node colluding with witnesses. How do you become a consensus node? Wallets with highest balances will automatically be admitted over time as needed. So, Helium has their node and their staking structure. Their validator nodes and their staking structure. And so Crankk is taking a similar approach, but they're essentially saying you can't really necessarily be a consensus node, but we're going to take whoever has the most coins in their wallet. Basically, we're going to take the rich list, and we're going to make those consensus nodes. It's very odd. It's really kind of centralizing those consensus nodes. There's a bit more to symmetric and asymmetric key cryptography as well as message signing being used here, but we'll come back and explain that at a later time. Gas fees paid in Kadena. So this is another key thing. Because they are on the Kadena network, you have to hold KDA in your same wallet as your Crankk token because it's used to pay gas fees, right? So keep that in mind, that if you're running one of these gateways, you always have to have Kadena in your wallet. Since we take advantage of the Kadena network to operate on, we need to pay the gas fees in the network's native token Kadena. It makes sense to minimize those gas fees. We've built our solution to always let the network calculate the minimum fee before sending our request, thereby guaranteeing that we pay the minimum acceptable fee for our operations. Furthermore, we optimized our smart contracts to use Kadena as a key value database to minimize the required minimum fee. Since as a Crankk network participant, you'll need some minimal Kadena balance, will include a complementary balance of KDA with every gateway purchase that should last you a long time to cover gas fees. So whenever you buy one of their gateways, if you buy it from them, they are including some KDA along with that. They don't indicate the amount, but they do say that they are including some KDA. So that is nice to see. I think Helium did the same thing, if I'm not mistaken. At least Syncrobit did when I bought my Syncrobit. That was a while ago. I was one of the early pre-orders. And I think they included, it was either $10 or $50 of HNT so that you could get up and running with it. Register it on the network, all that, without having to source your own HNT. The mining hardware is actually just a Raspberry Pi with a LoRa radio module. It should consume energy similar to Wi-Fi routers, so you don't need to budget for extra energy costs. The miner will come in an indoor enclosure with a basic antenna. It will be up to you to potentially get a larger antenna. Our long-term goal is to democratize access to both hardware and software And in that regard, we are working toward letting everybody build their own hardware and self-install software after we've proved the viability and robustness of the network. So for me personally, I'm going to be waiting until they open source that hardware and software. Right? I run Helium. I believe in Helium. One of the big reasons I originally got in Helium is because I like the idea of the decentralized IoT network. Right? I've built robotics. I've been into all types of IoT stuff over the years, and I see the value in having an IoT network. I just don't see a value in copying the first company that did it without really improving on it. And I'm not seeing anything that's improving on it. And this next section just talks about purchasing it. Yeah, they're basically just saying if you're an early adopter, they recommend buying two. In fact, early on they required you to buy at least two because they knew that if you had one, you weren't really going to get any coverage. This is different from Helium in that when Helium first started, they did those global pings. I forget the exact name that they gave them, but where you could essentially, you could globally witness almost or do like a ping check to somebody in a completely different country just to make sure the devices were up and running. They're not doing that. Crankk is basically saying, hey, until our network's built out, you need to have two devices so that they can ping check each other. But that's it for their light paper. I'd be interested in let me know your thoughts down below. If anybody has pre-ordered or actually purchased one of these, they're really not a pre-order. All of them are shipping within a couple weeks. Let me know your comments on the project. Let me know if you plan on getting one. And more importantly, let me know if you are going to hold out until it is fully opened up to DIY, or if you are going to purchase one of their pre-built miners.